Okay, this class is about linear algebra. So who am I? So my name is In Liu. I'm a faculty here in computer science and engineering, but I spent most of the time working for the company. So you can see there's a many list, right? So this is my 9th job. So I moved around many companies, but I joined Hanyang University about 3 years ago. Until then, I worked for the various companies like LG Electronics, Samsung Electronics, a startup like Altcast, which President Mrs. Park visited first time since she became president. Also, US companies like Unisys is a computer company. So DEC is mini computer company. Also Xerox Palo Alto Research Lab. So most of the time I spent my life in the company. So my view on the teaching might be a little different. Let's see. So this semester, we have 7 classes on linear algebra, right? So why do you take my class instead of taking some other classes? Why do you take my class? Because no choice, because software major have to take my class? Well, you can take somebody else's class. So linear algebra is linear algebra, same thing, right? So most of the other classes might be taught in Korean, but I don't know actually whether they are taught in English or Korean. Actually, this is the class I taught first. I'm teaching first time in linear algebra. No, can you guess when I learned the linear algebra? So how many years ago? 42 years ago. Okay, so I was a sophomore. Okay, second year in college. So I took linear algebra. After that, I never looked at it, right? So it's pretty much adventure, right, for me. But when I look at the content, which I have to teach you, it's almost identical. No, usually mathematics doesn't change that much, right? It's so basic. It's almost same content. So I decided to teach linear algebra on English and also to be videotaped. This is a big, big change to me, right? So officially, actually, we don't have any TA. Unless you have a laboratory, we don't have TA, but my graduate student will help you. So TA, I say TBD. What is TBD? Can you guess what TBD stands for? To be determined. Okay, so TA to be determined. Also, actually, we are recruiting mentor, but we haven't found yet. So mentor means last semester when you take 소입설, right? We hired some yours like 선배 or senior help you. Actually, this semester I'm funding 23 mentors for various classes. I'm trying to assign one mentor who got A on linear algebra last semester or 2 years ago, but nobody applied yet. So we don't have anybody yet. So if you have any, your 선배, to recommend as a mentor, please recommend me. Then you can ask help to him, right? As you know, I'm not that available, right? Sometimes it's pretty much hesitant to ask questions to your professor. So I try to provide such resources to you so you can learn from your mentor. So you don't have a mentor yet. Okay, here's text. Why do I have so many lists? It's a linear algebra is a very, very old discipline. Also, almost every student in engineering, also economics, in many areas, they take this kind of required class. So there's a big market, right? There's so many textbooks available. So this computer science division, each professor is choosing his or her own textbook. So this time I decided to take Gilbert Strang's book, who is a professor at MIT Mathematics Department. Also, his class is available online on YouTube. So anybody is taken any classes on iTunes? You can OCW, right? Open Coursera. So you can go actually. There's many sites available, especially MIT. Most of the courses are available for you to take. Okay, so I watched their classes last vacation. So my class is based on actually his lecture. It's Gilbert Strang. So his lecture has been available for many years online. So you can find YouTube. Also another one is some students here may have difficulty in English, right? So Sungmyeong Women's University, they got government grant to come up with Korean caption for famous English class. So linear algebra is one of the class. You can go, Snow is their site. Go there, you can watch his lecture. With captions appears in Korean, or transcript. You know what a transcript is, right? 녹취록, right? Transcript, right? Or transcript in Korean. So there are many sources available to learn about this, text area. Actually, same for almost every class in computer science and software engineering, software, right? Most of the similar classes are even artificial intelligence, yes, available there. Java programming, yes, somewhere there. So you can choose whatever best class is to you without paying any money. So actually, you don't have to take your professor's class. Some of the classes might be much better, as far as you don't have any language problem, right? So this class, unless we are interacting, just ask questions, listen. Without much interaction, actually, it's not better than taking just online class, right? So I really invite you to participate in discussion. Simply listening to lecture is very, very ineffective. Most people say only 10% effective, just waste of time. That's why actually somehow you have to study only like yes, right? Then during this meeting, we have to spend more time in discussion, okay? Oh, got to go back. How can I go back? So linear algebra is a book. Actually, Gilbert Strang, he wrote 2 books. Actually, so linear algebra and application, it emphasizes more on application. Or introduction to linear algebra, that class is taught to mathematics and engineering department. Or you can take either of, you can buy either of them. But this one might be cheaper. We have some Asian editions available. Second one, probably not. Also, it's a Leon's book was used by other faculties in our department. So you can take that. Also, actually, this another book is Coding the Matrix. This is a book just published only a month ago. I just was able to get that book just 2 weeks ago. That book actually is more content on what's the application of linear algebra in computer science area. Especially when you learn mathematics. Why do I learn this? Do I have to learn these things? Do I have any chance to use it? And this Klein's book has many examples of application of linear algebra to computer science. But many of the topics in computer science you haven't learned yet. But still, by just scanning through, you may have some idea, oh, that's why I have to learn these things. Okay? Last book is Advanced Linear Algebra for Engineers with MATLAB. What is MATLAB? Have you heard about that or not? MATLAB. Have you heard about Python? Yes, right? Have you done any scientific programming using Python? No, right? In order to use computation on Python, you need library, right? Like graphic library for graphic, right? UI library for UI, right? Scientific computation, there are two libraries available. One of them is NumPy. They call NumPy. The other is SciPy. You got Python, scientific or numeric computation. So their library has lots of libraries already built in for linear algebra. So using their library, actually you can solve most of the problem using computer programming. You don't have to use any hand. Okay? MATLAB is math, right? Mathematics laboratory. It's a computer language which is primarily designed, used for engineering computation. So this book has all the functions or routines available for linear algebra. Once you understand, you just use it. You don't have to write any program. Okay, matrix multiplication is there. Inverse of the matrix is there. But you have to understand it. How do I use them properly? When you misuse it, you are in trouble. But actually, you don't have to write programs for all these algorithms in linear algebra. The same thing, actually, graphics, other areas. This area is pretty old, right? Some of your old generation, your 선배, somebody else already wrote a program. You just simply use it. So when you are have more interest in what kind of applications on computer science, just buy this book. It's $29. It's not expensive. Okay? This one is standard text. If we are more interested in, okay, I really like to use it, special program, take this book. There are tons of books available in linear algebra, probably more than 100. So you have to choose the right one, right? It says, oh, $29. Oh, I don't have that much money. But when you go to online, some free books are available as well. Yes, most of them are written in English, right? Also, many Korean translations are available. So it's up to you, actually, which books you are using. I do not require you buy any specific books. It's up to you. Okay? But, you know, I know it's, in your case, most of the tuitions comes from school, right? But when you pay full tuition, how much you are paying? Oh, week. For 330만 원, right? A week, right? So save some money for textbook. Still spending that much money for tuition, it doesn't make sense, actually. So I actually strongly recommend to buy some books and read it. As I said, lecture doesn't give you that much information or that much help. You have to learn for yourselves. So you have to read the books. Also solve the problem. Okay. This is grading policy. I'll give you some homework assignment. It's 20%. Current plan is I'd like to give you 2 midterm exams. Haven't decided yet. Especially this semester, we have many holidays, right? So in case I give you 2 midterms, each will count 20%. If I give you 1 midterm, it will take 30%. Okay? The final exam depends 30 or 40% on participation. This is policy. It's basically do not cheat. Do not copy any homeworks from your friend. There's no exception. If I find it, that person will be given F. Very generously, right? In general, when you find the cheating, you will be kicked out of school. 퇴교. It's that simple. But I'm not that bad person. I just guarantee you give F. Don't copy it. Me and my TA will look into very, very carefully. In my C program, I had experience to give F because of that. Okay, do not copy. Also, another recommendation or requirement is place your name tag on your table or in your PC. Okay? Yep. You have to give the name tag. Why should I ask that? I'll give you many, many questions. So I have to know your name. Okay? You have to answer. So I'll take your participation into consideration when I give you a grade. Okay, you have to participate very actively into discussion. Okay, sometimes actually I ask you to lecture for me. Okay. Also, you have to attend. We have to attend this requirement, right? So you have to satisfy them. So I'll just pass this sign-up sheet. You just sign your name. So my TA will count how many people here. The number of them is matches. It's simple, right? When mismatch occurs, then we'll check. So every class, I'll just pass around this. If we're late, then that person will be also will be recorded. Okay. So there's no excuse of essence. Okay, just be here. So also, I'll quote the saying what Woody Allen, who is a famous actor. Your parents may know him, but you are too young, right? So he said, 80% of success is showing up. Especially appearing, attending class is very important. Especially for me, is rather than following textbook, I like to give my own perspective, which might be different from textbook because of my background in the industry. So they may be very unique compared to what textbook says, okay? So official language here is obviously English, right? So have you taken any English class or not? Speak up. Have you taken any class in English?
Yes, I did.
So what was it?
It's determinism integral class.
Okay. So as you all know, you have to take class in English, major, right? Computer science major in English before, to graduate, right? How many of them? 5 of them, or I don't know, 5, right? So I asked student, should I teach my software engineering in English or mathematics? Software engineering, there's no Greek symbols, no mathematics. Everything is text, purely. Purely there's no equations at all. So student has lots of difficulty. They says, okay, please teach mathematics in English. So just learning math in English or Korean do not make that much difference. So that was a student recommendation. So I respect the customers, right? You are my customers, right? So I follow that. That's why I decided to teach linear algebra in English, so you don't have to take software engineering in English anymore, right? So that's good for you. But in case you have a big difficulty in communicating in English, especially raising question in English, then speak up in Korean. Okay? Learning is more important than communicating in English, right? Then I'll do my best. So hopefully just English communication just deter our effectiveness, right? So in case you have difficulty, you try it out. So you can learn both, right? You can learn linear algebra as well as English, right? But we are not there yet, right? So in that case, just ask question in Korean. Also, whatever my lecture or explanation is not clear enough, then you can ask, can you explain this in Korean? Then I will do. Okay? So, the class should be interactive. So your feedback, your opinion is very important. So we have to make our classes more effective, right? That you have to participate, you have to give your opinion, right? Do not hesitate giving your opinion. Okay, also homework and reading assignment should be carried out on time. Okay, how many mathematics classes do you take this semester? Oh, poor student. This is a very unfortunate, right? Really, it's very unfortunate. Unless you like math, right? Actually, I'm sorry, this is very unfortunate. Somehow, department changed the policy. Okay, linear algebra used to be taught in spring of sophomore. Okay, somehow they changed it. So this semester we are offering 7 classes in linear algebra, right? For both freshman and sophomore. But in my view, it makes sense take linear algebra earlier. So I'll try to explain to so many mathematics classes you are taking or you have to worry about it. You took calculus, right? 1, right? Now you are taking another calculus 2, right? What is calculus? Can you explain, green shirt? You are taking this class, right? You have to go to your mom to explain, oh, I'm taking calculus, right? You have to explain, right? Mom is giving you tuition and money. You prepare, all the food, right? Then you have to explain to mom, I'm taking this calculus, which is gonna make you make a big money, right? So when you take some class, you have to understand it. Why? What's this about? So what calculus is about? Because Hanyang University required it, I hate it, but I have to take it. That's not good, right? So you have to be able to explain to your girlfriend what this is about. So how do you find out this calculus? Then, okay, I have no idea. I have to go somewhere to try to find out what this is about. So how do you find calculus? Internet, right? So on the internet, which site do you want to go? Mathematica is for the advanced mathematical tool, right? How about you? Google search? Yeah? You don't know? Then anybody who has a good idea? Whoever give a good answer, I'll buy ice cream next time. I'm going to just bribe you. Wikipedia, right? So Wikipedia is actually a very good place to go find out the meaning of most of the terminology you face. So, I just linked it here, actually. Calculus. So, just read the first and second paragraph. Probably here is too little, but you have your screen here. So calculus is about dealing with changes, like differentiation in integrals, right? Or some changes of quantities. So you have to understand that, right? So each subject area you are learning in mathematics, go to Wikipedia or take this in the slide, click it, just read, not all of them, right? It's many pages, right? At least just one page of content, you just try to read it, understand it. That's what, then at least you have some feeling why I should take this. Or sometimes why I should ignore this, right? I'm going to concentrate more on something else. This seems not interesting. So you have to make a choice, right? I'm not asking you to take every class, you do well on everything, right? But you understand those topics, then you have to allocate your own time and resources and set the expectation. I'm not asking you to get A on all areas. Sometimes it's okay to have a C on this area, but some of the area you choose, you would like to have A. If you need any help, you can ask your 선배 or professors. Okay? Sorry about that. Always young people is much better than I am, right? So probability and statistics, right? So you are taking this class, right? So who is your teacher? Professor? Oh, Kim Kwang is new faculty who joined us. So depending on the class, actually, probability and statistics. What text do you use? Do you have any idea? What textbook? There's no name on statistics, right? So basically, depends school. Sometimes some professor take class in probability and statistics, more statistics. Actually, based on your text, probably we teach probability and random variables more than statistics. Actually, my preference is teaching more on statistics. But each area, by clicking that, try to understand it. Okay? So basically, try to understand what you are getting, also what you are not getting. Okay? Because professor doesn't provide you everything. They provide something, but they do not provide some other thing, right? Which might be very, very important. But everywhere you go, okay, they provide some interesting thing and useful thing to you, but they don't provide other things. But if you want other things as well, you have to do your own. The same thing in your software and everything. Okay? Another class you are taking is discrete math, right? So by clicking the try to understand. Discrete math is the class mainly taught to computer science department. Like electrical engineering, mechanical engineering, they do not learn. So basically calculus, probability, statistics, linear algebra is most common for all of the engineering classes. But discrete math is mainly for computer science because it's just collection of various topics. So then linear algebra is the area I'm going to teach this semester, right? But in high school, you already learned the algebra, right? What's the Korean translation of algebra? 대수. Have you learned in high school? Have you learned it? You learned already. I bought 수학의 정석. Actually, I tried to find out what is a high school student learning because I went to high school about 45 years ago, right? I don't know much about what actually they are learning. So I bought just 수학의 정석. 송성대, who is famous, right? Yeah, who is founder of the high school, right? 상산, right? So even he was famous when I was in high school. Anyway, so I just bought them, then says, what do they teach? So actually they are teaching vector in high school. You learned it, right? You learned matrix, right? As well, right? Also you learned Gauss elimination, 소거법. You learned it, right? So actually many of the topics actually you already learned. So you have free lunch. Oh, it's easy. I learned most of it in high school, right? That's good, right? You can get a grade very easily, right? Even when you see the calculus, 미적분, right? You learned it, right? Have you learned any new in college or not? You already learned like the differentiation and integral in high school, right? Why do you take this calculus in college? You already learned it. It's like mathematics is always like you learned it, then learn more like onion, like 양파 껍질, right? Onion, right? You learn this, then with some repetition, learn more. Not like you learned, oh, this is complete new topic. Start from scratch. Learn something else. No such a thing as mathematics. Almost every area you are learning in mathematics, many of the things that you already know. It's basic understanding. But on top of that, you are learning more. The same thing on linear algebra. So you already learned basic concept of algebra. So we teach them more formally. Formally means I can explain easily, or I going to explain in more difficult way. That somehow is formally. Okay? So that's a linear algebra. So you are talking algebra. Then algebra is like what's arithmetic, right? What's the difference between arithmetic and algebra? Think about it. Or click these things, then go to Wikipedia. Try to learn about what do they say. Okay? Also, we don't teach here, but after learning linear algebra, this advanced topic is abstract algebra. Actually, some of the concept there is pretty useful. But when you go to graduate school, you may have to learn. But here, you don't have to. But this is the area. Then so we are selecting certain topics is mathematics we are teaching it. How many areas is mathematics? Then click this list of mathematical topics. Go there, try to find a list of the areas. From there, you can say, oh, this is the area we are learning. Or this is the area we are going to learn next year. Or this is the area we do not learn, but I don't have to worry about it. Oh, this is the area might be very important when I learn cryptography, like 보안. Oh, that's the area we have to learn, like number theory. So basically, analyze what your interests are. Based on that, you may have to learn certain areas of mathematics, unfortunately, for yourself. Okay? So at least you have some kind of ideas. This whole mathematics. Oh, this is the area we are learning. this is area we are not learning, this is important, or this area we can ignore. So you have to have some pictures. In order to dive into this area deeply, I like to recommend you have some kind of concept, overall picture. Okay? That's why I'm explaining these things. Any questions? But still, it's very unfortunate for you to take 4 math classes at the same semester. So blame teachers, okay? It's their fault, it's not your fault, right? Yes. Okay. So what is linear algebra? Yeah, vector spaces, all these things. So I can explain these things, but it's English, it doesn't help, so I explain with some. So just later you can just refer to these things. Basically, we are learning about matrix. You already learned about matrix in high school, right? So in a way, it's not much new. Mastery is very, very important. So linear algebra is about systems of linear equations. You know all this English translation. Then about matrix. Then I can ask you, what is more important? Which is more, like, calculus is more important or linear algebra is more important? Give your own opinion. Like, calculus you are taking 2 semesters, right? Linear algebra only 1 semester, right? It means calculus should be more important, right? Is it true or not? It's a good argument. That's probably true for mechanical engineering. Computer science, you have a very, very little chance to use calculus. For EE, like electrical engineering, yes, you have to learn about this calculus. But computer science, really, all the courses later, it's okay even not to take any calculus class at all, except few areas. But linear algebra, unless you take linear algebra, you are in trouble. So in that sense, linear algebra is more elementary or more essential to computer science student. For the mechanical engineering, calculus might be more important. But we are not dealing with such issues. Okay? So this is college level, every school teaches, even some of the areas actually, this class is taught in high school. So my daughter took this linear algebra while she was in high school at UCLA. So many US, in many high school students go to college, they take college level classes. Okay, so that's the way it is. So some of them here actually went to whatever this 과학고, right? Probably you took some high level classes, right? So first year in like a freshman, you are free, right? You probably learned most of the topic already. Okay, so this is whatever areas. Then I just skip things. Then OCW. So OCW open courseware. As I said, many engineering classes, special mathematics classes, there's a big market for mathematics classes, many classes available online. So you can go there, take it. Sometimes actually certain classes actually even take it, so exams or quiz, even you can get credit. Okay? So you can take like the Khan Academy, MIT OCW, or EDX. Almost every school, famous school in US has their courses available online. You can go there, take. You don't have to take any Hanyang University class at all. You can take so many classes available there. Okay, that's the one thing. Okay, so it means there are many ways to learn. Actually, you don't have to show up these classes. You can take that, actually. But we decided to also provide our class as OCW. But what kind of quality we are getting, I don't know. Especially, I'm teaching this class first time in my life, especially, 42 years after I taking class, right? So it will be very interesting. Okay, any question on this orientation? Okay, then let's move on to main topic. Then when you're modeling, modeling is not perfect. Sometimes actually modeling. So when you have a model, it's always some kind of inaccuracies introduced. So you have to find out what they are. So you have to find out when you have modeling, is it good enough or not? As I said, we are ignoring weight of bar, right? If that's not the case, you don't have any good model, right? You have a very poor model, right? But solving that equation doesn't make sense unless you take into consideration, right? Because in most cases, you are not trained to deal with such a problem. Always equation is given, solve it, solve it, solve it. But for me, it's modeling, modeling, modeling. Whether modeling is good enough is much more important. Even my daughter is working for Goldman Sachs, working for investment bank, right? She studied computer science, but her modeling is modeling stock market to make money, right? Or check on bond. So modeling is very solving. That's computer will do. So modeling is very, very important. So you have to understand it. So in that case, model in this case, models, we just model as linear equations. What is a linear equation? Which is 4 times x rather than 4 times x squared. It's quadratic 2차 방정식, right? Or log x. We are simply just constant multiplied by just first order variables. Then whatever summation, that's a linear equation. Okay, that's very simple equation. Sometimes too simple. Okay, it may not reflect reality. So you have to choose. Why do you choose these linear equations? Yes, simpler. Is good enough? Don't know. So that's why when you model, we have to choose how you model it. Now you decide to have a model. Now you have parameterized the parameter, right? Then your parameter is length from whatever this middle point, right? Somebody has to measure it, right? Measurement is 4.03 or 4 or 4.035, right? The number should be measured, right? But this is whatever you are sitting on it. There's no single point, right? Your foot is wider, right? So you have to estimate length, right? Distance, right? What's the exact distance? Do you have a really exact distance? This is approximate distance, right? This is estimation, right? You may say, oh, I'm going to measure 10 times, then I'm going to average them, right? That's the one way to have a better confidence. But still estimation, right? So you did a very, very poor job on estimation, then you solve it. Doesn't matter that much, right? It's very important, right? That's why when you estimate, this is the real problem I'm talking about. Okay? The second problem is, yes, I estimate well. Then I'm going to solve the problem. But when you represent two numbers, let's say 2, integer 2 in computer, can you represent integer 2 in computer exactly? Can you do that? What's the computer representation of number 2? You learn some programming. This is 1 or not? In computer. Approximately, 그지? Right, approximately, right? You know that, right? You know what I'm talking about, right? When you compute in hand, yes, this is 1. Perfect 1, right? But when you computer or calculator, might be, let's think about it, approximately. Oh, how much percentage better? Don't ask me. You are asking too difficult question, right? When you have so much computation. So when you have representation, yes, there is no way to represent these numbers exactly on the computer. Also, when you have computation, there's lots of truncation errors, right? You know, it's like in the calculator, you experience a lot, right? When you work at big numbers, you're in trouble, right? So basically, there's lots of approximation here, lots of approximation here. So yeah, lots of modeling is equivalent. So when you solve that, so when you're modeling, you have to take these things into consideration. So here is basically is a representation. Let's say 2x, I'm not able to represent 2 exactly on the computer. That's a representation error, right? It's easy, right? It's obvious, right? Okay. So this area is just my own materials. I thought it's very important, especially to engineering or computer science student. That's why I just added. The second step is once you're modeling, then solving it, right? Then solve it, right? Oh, we are expert in this area. We know. Just give me equation. I know how to solve it, right? Linear equations, you already know that, right? I know how to solve it. Just give me some time. I will do that. Okay, if you give me one problem, I solve it with my hand. When you give me 100 problems, yes, I write a program in Python or Java, or you haven't learned Java yet, right? C or whatever. So 1 week later, you want to give me all the answers of 100 problems, right? That's not an issue, right? So when you solve it, so basically from abstract model, you can find unknowns, right? So you can use it by hand or using computers. You can write your own program. But linear algebra is so old discipline, somebody else is already wrote a program. You can use it, right? You don't have to write such your program, right? Why should I? It's already working there. It's free. So MATLAB is one of the typical programs you use. So actually, I do not discuss such issues. But whenever you have homework or assignment, try to use MATLAB, which is freely available from Hanyang University website. Okay? Because most engineering students use it, except computer science. Because most engineering, they live by linear algebra almost every day. They have to use it almost every day. Computer science, not that much. But when you have a problem, usually you can go there, then try to solve the problem using computer. Sometimes you have your homework, you have to solve by hand, right? Then you can verify against the program, right? Oh, that's the program. What's their answer? Okay, I feel confident. Okay, so when you solve a problem, there's 2 areas you have to consider. One is accuracy. As I said, when you solve a problem, there's lots of computational errors, all these truncations, all those things. So answers you are getting might be approximate, right? Sometimes too much truncation, you make it garbages. So unless you understand these things, you trust the computer program so much. Even though it give you garbages, you trust it. Then you are in trouble, right? That's why you have to understand these things. Second is efficiency. How long is it going to take? Okay, come back here 2 days later. Okay, wait 1 second, I'll give you answer. It's depending on what kind of algorithms you use, efficiency will be different. So you have to understand those things. It's simply more than computation. You have to understand. Then you have to understand properties, all these concepts, which are very important. So in my view, mathematics is not about computation. It's about concept. You have to understand concept well. The mathematics in high school for you is mostly arithmetic, just computation. Computation is useful to make your concept concrete. Okay, concept is more important. Also, based on concrete understanding of concept, you say, okay, I'm going to apply this concept here in your problem, right? There. I know what's the pros and cons. What's the good things and the bad things, what's the things I have to worry about. So you have to understand that. Simply just solving it, following it, it doesn't have that much. Yes, you can get A in the class, but it doesn't have to be that much. Okay. Then this is more system linear. This is more or less a review on the linear algebra class you took in high school, right? You know everything. So now is solving system of linear equations. You know that. This is equation, right? So what are you doing? What is this Greek symbol? Rho, right? So what is just multiply first equation, first row by 4. You know how why we did these things, right? Multiply 4, the same thing, then we're just saying from this equation, we just subtract this equation, right? Then we have this one, that one, right? So that's the way we can eliminate, right? So we all know that, right? There's also another one. Now, okay, this is equations. Oh, now G is now 2, right? Then you can substitute all these things, right? So this is 9 by 9 equations. You can do that, but it takes time, right? But also I said, when you have too much computation, computation errors will build up. When you have 100 by 100, finally you solve it, but your actual answer, when you substitute it, it may introduce lots of errors. It means here I says equal, right? Computation actually is more or less approximation, right? Because of computational errors, right? This is a mathematical on the paper. Yes, that's exact solution, right? But what you are getting on a computer, just remember, that's approximate solution. When you accumulate all these computational errors, suddenly, rather than getting 2, you may get 5. In case you have so many computational steps. It's entirely possible, right? Let's say you just multiply by 10,000 times. Can you guess what you are getting? Just, truncation or rounding or whatever, then you are getting something strange numbers. So later you have to verify that. Okay? So these things anybody learned already, right? Okay. So this is called Gauss method. Gauss was genius, right? Who was 300 years ago? So he did many big contribution on mathematics. Okay, so I don't want to explain that. So now, so your turn to explain this equation. I'm tired. So I said systems without a unique equation, then whatever those equation, then the solution. So can you explain?
두 번째랑 첫 번째랑 빼면 y만 남고 y 알고 번째 2배 해서 두 번째랑 더하면 그래도 y가 나오고.
Just read this systems without a unique solution. Here everybody assumes, oh, this linear equations is m variable, right? When you have n equation, we can solve it, right? Right? But that's not true. Some specific cases you cannot solve. Or you can solve it, but it's very strange. These three equations here, I try to solve it. Some conflict. Okay? It means there is no solution available. Okay? No? There's no solution. So equation was given to you. Okay? Then you try to solve it. Here is we have only one set of solution, right? That's a typical. But some cases, there's no solution. What's a linear equation? Like linear equation, you can represent as a line, right? Two lines are in parallel in the space. They never meet, right? Because there is no solution, right? You can say this is, in a way, the case, right? They never meet. But equation is equation, right? Then we try to formulate this more formal way, but it's basically the same concept. This is another example. It says infinitely many solutions. From the equation, it's obvious, right? Why do I say obvious? You don't have to solve it, right? You just, by checking this equation, oh, that's obvious. Why? Why so obvious? For 3 variables, you need at least 3 equations, right? 3 variables, 2 equations. So in that case, oh, that's obvious. Right? For 2, always you need like it. So in this case, it's very obvious. So there are many, many solutions. So infinite number of solutions are available. Okay? This is bottom up is another example. Okay, this one, oh yeah, 3 variable, then 3 equation. Okay. Still, when you try to applying the method you learn in high school, still we have infinite many solutions. Okay? So even in the linear equation, sometimes you have only one unique solution. Sometimes there's no solutions available. Sometimes there's infinitely many solutions available. So you have to understand in which case on what. So we can explain this very nicely on paper. But probably it's computer, in my view, nobody telling that, but all the computation is not perfect. It's approximate. And so when you have such approximation, even though this is no solution cases, they may have very interesting, there's some misjudge that. Because of the computational errors, because of the representation errors, you may experience very funny things. Okay? Okay, this is end of class. So Just give me any questions. Unless you give me any questions, I'll just appoint you, just enforce you giving me questions. Any question?
저 자료는 어디 가면 찾을 수 있어요?
That will be available on online. Okay? This class, actually, I use PowerPoint, right? From now on, I don't want to use my PowerPoint. I just use handwriting, mostly. Okay, initially it's concept. And next time, actually, I use PowerPoint, but just blank paper. I'll use my tablet to write. But after class, the handwriting will be available. So this just PowerPoint, I can make it available before, right? Handwriting, mostly just table of content. I just try to make it available online. So in that case, that's the case. Another one is in case when I use some other method, even handwriting is not available. So in that case, only video tape will be available. So I'll try several different methods. Any question? There's no project, right? The project means just it involves several weeks, right? This one is basically homework, the exam. Homework and exam, like midterm exam, final exams. Currently, I'm thinking about 2 midterm exams, 1 final exam. But problem here is we have so many holidays this year, right? So we have to make a class. So I don't know whether to have enough. So who is 과대표, representative here? So discuss with our TA, come up with the schedule for the 보강 class, maker class, right? We have to come up with 4 maker class. 추석, whatever holidays, then whatever 한글날 or some of the holidays. So we have to come up with 4 holidays, so maker classes. So mainly, I don't want to give any quiz, just homework assignment and exam. So in order to have a distinguish good and not so good student, I like to give some 3 exams. Any other question? So how was the class? Was it easy or interesting or boring or? Exciting? This is not the exciting topic, really. What's your view? Okay, I'm going to conclude my class. Next class, I'll teach you some kind of geometry of linear algebra, mainly of the concept. So as I said, I will discuss mainly the concept. All the computational derivation is there on the book, right? So I don't want to repeat them. I mainly focus on the concept and its application to reality. So that's the area I'm going to teach. Also, you can learn from many topics. Also, I'll give you many homeworks which I take from different sources. But really, sometimes you say, oh, I understand that. But really, to find out you understand or not, so solving the problem, you finally realize you really know or not. Without solving that problem, actually you don't know actually you know or not. It's a simple exercise. That's a part of learning. Okay? Any other questions from that side? Okay, next time you just come out with your nameplate, right? Yes. Okay, see you tomorrow.